Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. Put a magnetic plate in the experiment area. Place 2 styrofoam cups nestled inside of each other on top of the plate. Drop a stir bar into the cup, which will be turned by the magnetic plate, and spin. The spinning will mix the reactants. Measure out your reactants, being careful to tare your scale to get an accurate mass. In this case, we are dissolving NaCl in water. Put the temperature probe into the cup, ideally using a clamp of some type. Put the first reactant in and measure the temperature for a predetermined time frame to establish a baseline temperature. Then, add the next reactant and record the temperature of the surroundings long enough to get a complete temperature graph for the whole reaction. Once you are finished, carefully dispose of your materials. Calorimetry is an excellent tool for determining the type of reaction that occurs in solution. Keep in mind that the probe is measuring the temperature of the surroundings, which informs us of what is happening in the reaction. The reaction will either be endothermic, causing the surroundings to give energy and heat to the reaction, or, as in this graph, it is exothermic, releasing heat and causing the surroundings or the spectator molecules to increase in temperature. On a practical note, please make sure that the lid you use fits securely and also has as small of a hole as possible in order to limit the amount of heat that can escape. If you would like to be very precise and accurate, use a professional grade calorimeter versus a calorimeter made out of coffee cups. Calorimetry can be used alongside Hess's law to find the enthalpy or heat of a reaction by adding together the data from each of the reactions, and also to define whether a reaction is exothermic or endothermic as previously mentioned.